Hello and welcome to my channel Physics with Fun. Here we will discuss about the very basic concepts of the physics. In today's video, we discuss the equation of motion and their derivations. There are three basic equations of motion as shown in this picture. In these equations, u is the initial velocity, or we can say velocity when time is equal to 0. V is the final velocity or velocity after time t. T is the time taken, A is the acceleration, and S is the displacement of the object at time t. Let's see the first equation, V is equal to u plus at. This equation is also called velocity-time relation, as the formula for acceleration is change in velocity divides change in time. To find out the change in velocity, we simply subtract the initial velocity from the final velocity. And also, by the same method, we can find out the change in time. Therefore, the formula for acceleration will be final velocity minus initial velocity divide final time minus initial time. As v is the final velocity and u is the initial velocity, therefore a is equal to v minus u divide t minus 0. Here, 0 is the initial time, or we can say that the object is at rest. Now, at is equal to v minus u, and from this equation we can say that v is equal to u plus at. This equation is velocity-time relation, which gives the velocity of an object at any time t when moving with initial velocity u and uniformly acceleration a. Our second equation is S is equal to ut plus half at square. This equation is also called position-time relation. As we know that the formula for average velocity is the addition of initial velocity and final velocity divided by 2. Therefore, average velocity is equal to v plus u divided by 2. And also the formula for total displacement is equal to average velocity into time. Here we have S is the total displacement. Therefore, by putting the value of average velocity in equation of total displacement, we have S is equal to V plus U divide 2 into T. In the resulting equation, we put the value of V from velocity time relation, which is V is equal to U plus AT. Here the equation will be S is equal to U plus AT plus U divide 2 multiplied by time. Here we add the both initial velocity and we have 2u plus at divide 2 multiply time. By solving this equation we have s is equal to ut plus half at square. This equation is also known as position-time relation. Our next equation of motion is v square is equal to u square plus 2as. This equation is also known as velocity-displacement relation. To derive this equation, we need the first two equations of motion, which are v is equal to u plus at and s is equal to ut plus half at square. From the first equation, we can derive the value of t as v minus u divide a. Now put this value of t in equation second, which is s is equal to ut plus half at square. Therefore, the equation will be s is equal to u into v minus u divided by a plus half a v minus u divided by a whole square. Let's solve this equation. S will be uv minus u square divide a plus half a into v square plus u square minus 2uv. Here we applied the formula v minus u square, which is v square plus u square minus 2uv. By further solving this equation, we have 2as is equal to v square minus u square. From here, v square is equal to u square plus 2as. This is our required equation, and this equation is known as velocity displacement relation. There is also another derived equation which known as displacement in nth second of motion. The formula for this equation will be S nth is equal to u plus half a 2n minus 1. This formula can be derived from the position time relation. So this is all about the equation of motion. Thanks for watching.